Hey everybody, Mr. Regan here, and today we have explored a common ancestor Australope population and looked at how this common ancestor went through speciation to create these new descendant species that we see within our simulation. Based on our data, we were able to see that when we take our common ancestor and put them into different environments, we see some common structures begin to change, whether that is the neck that we see here for our Australope in environment A or the jaw that we see here for our Australope in environment B. In either case, they both have necks. In either case, that neck obviously was a shared structure from their common ancestor, but obviously one of them changed based on their environment, and same with the jaw. So let's go ahead and take a look at how that happened and why. So we know that our common ancestor has a lot of the same structures as our descent species with a few changes. In order for that to occur, speciation needs to happen. This idea that our common ancestor is split into two environments where certain traits are adaptive and certain traits aren't. So when our population was split into environment A with the taller thorn palms, we know that the longer neck was the adaptive trait. So the ones with the longer necks were able to get the food they need, eat, survive, and reproduce, and go through that natural selection, passing on their traits to their babies. And then over time, the ones with shorter necks won't survive, and then the ones with longer necks will. And we see more long necks within their descent species than anything else. In fact, those are the ones that are left over many, many generations. Now, our descent species still has some of the same traits. It has the fur on the back, the legs, the small tail, the head shape, and such. But we can see that difference in that shared structure, that neck that it had from its common ancestor, versus the other species, descent species B, that went through speciation, but environment B. There, the large thorns make it hard for species to eat, and only those with large jaws are going to be able to survive. And because of that, the ones with small jaws can't eat those large thorns on the thorn palms and they'll die. The ones with the big jaw will obviously pass down that trait. So natural selection occurs, making the large jaw the adaptive one, and they're the ones we see in species B. Again, these guys have the same traits in terms of fur, tail, and feet, just like descent species A, but that shared structure of the jaw that we see is different. These two might have the same jaw, but these two don't. These two might have the same neck, but these two don't. That separation of shared structures from the different environments and that change that occurs through natural selection leads us to see descent species with different traits. So, even larger changes can occur when a population spends more time in the environment and that environment continues to change. The more we see changes occur, the more we see our Ostrilopes change. So, if this Australope lived in a yellow environment that changed, then we'd probably see more yellow Ostrilopes. Even less change occurs when populations spend a longer time in an environment that does not change. So, this population, descent species B, will stay the same or roughly the same if the environment stays the same. Whatever is adaptive in the environment will show up in the population's trait. So, the stability and change of the traits within the population depend on the stability and traits of the environment. We're going to summarize what we've observed and what we've learned with these ideas and in our sim in the next task when you complete the drag and drop activity. If you have questions on how to complete it, reach out. Otherwise, good luck.